Assalamu alaikum friends. In the previous video, we have discussed the idle IC, and as you can see, the numbers are getting increased by one by one after the clock pulse arrives. Uh, but as we were making BCD count, it should be from 0 to 9, and it must get back to zero whenever the 10 arrives. So as you saw the thumbnail before, it was written as a reset 10 to 0, that whenever the 10 arrives at the input of any combinational circuit, there should be the four inputs and four outputs, as the 10 should be is 1010. It comes in the form of four bits, and it should be turned to be zero as the four bits with all of the bits of a 4-bit number be zero. Like we are resetting 10 to zero. Now here 1010 to 0000. We have designed a combinational circuit using logic gates to achieve this task. First, let us discuss about the logic gates. The first one is the AND gate. AND gate, the simplest key to understand this gate is that it only gives its output high when its both inputs are high. If any one of the input is low, the output of the AND gate would be low. You can verify this statement from this truth table. For the OR gate, if any one of the inputs from this A or B is 1 or high, our output will get high. But if both of it will be only 0 if both of the inputs are 0. In NOT gate, it just does the complement of its input. Like if A is low, its output would get high, and if A is high, the output will get low. Like it is complement. You can also say this as A bar. It is also represented by bar. uh, Moving to a circuit, as I told you before, there should be the four inputs and four outputs. Here you can see a 4-bit number is given to this as four inputs. It just transfers the same number which is given as input to the output to this 4-bit number output, same until the 10 arrives. But as the 10 arrives at this position, this combinational circuit, according to its methodology and working we have made, uh, it comes it makes these outputs to be zero again, and the cycle repeats itself from 0 to 9, and these outputs are again given back to the flip flops. To achieve to how The question arises, how we have made or designed this combinational circuit. Any of the combinational circuit always requires a function. We also made a function for this circuit which resets the 10 to 0. As I told you, it must have four inputs and four outputs, as the number are of 4 bits. Here is written 9. This is 9. This is 8. You can see that till 9, all of the number are replicated as it is from input side to the output side of our desired circuit. But after 9, as the 10 arrives, our output reaches to be 0. If I consider these all conditions to be don't care, it is also correct, but to avoid any risk, we have made these all of the conditions to be 0. Like when any of the number greater than 9 arrives at input, its output gets 0. But this line was enough to achieve our goal. Now we have to make separately the function for this w, x, y, and z, and we did so by using the k maps. We just got these simplified functions of all of these outputs. This one was for z, y, x, and w. In this, using these logics, these were the four inputs: a, b, c, and d. You can see all of the four functions just only consist of the literals, which were from the input side, these ones. And our outputs are the outputs after these uh, function implementation of w, x, y, and z. This is this that combinational circuit made here. We its simulations had been done. Now the thing you have to note that when you have noted before that when the 10 is arrived here as and given, and the same number is given to this combinational circuit, it makes this whole number as 0 and gives back this as the input to the flip flops. Now you will note this, it becomes 10 and this becomes 0 due to all of the our logic we made using those truth table and k maps. In this way our whole of the circuit is working. You can see this was the clock we have discussed about before. These are the flip flops. This is the adder part. Original. This was the output given, coming out from these flip flops. This was the adder where 4-bit adder IC was used for the incrementation. And after these increments, when our output becomes 10, this combinational circuit resets it to 0. These are small of the some two LEDs are blinking here. Let us discuss about this. These LEDs indicate just that the number at this original output is even or odd. This thing can be achieved just by making a logic at the last bit of any number. That every any number, any even number always have 0 at its least significant bit position. Any number with the least bit as 0 is considered to be the even number, and any number with the 1 at its least significant bit position is considered as odd number. So this green LED indicates the even number and red LED indicates the odd number. Thank you so much. Here we have concluded our DLD project in which we have discussed about all of the basics of DLD. Thank you.